Good day and welcome to another micrographics webinar. We are an Autodesk partner and reseller. My name is Sean Bauer and I will be presenting this webinar today, 27 August 2024. I'm an applications engineer and AEC technical consultant with micrographics, and today's topic is Forma, daylight potential analysis. If you find this webinar to be informative, please like this video and subscribe to our channel for future webinars. Okay, let's get into it. On the agenda for today, we will start with a short introduction to Forma and daylight potential analysis, understanding vertical sky component VSC, setting up daylight analysis in Autodesk Forma. I will show a demonstration for the workflow, how to bring in a model or create a massing structure in Forma, how to set up the daylight potential analysis, choose the area, zone or site limit or the entire model, and then how Forma determines the analysis based on surrounding buildings and vegetation. Interpreting daylight potential analysis results with a comparison to other analyses such as sun hours and wind. Applying daylight potential analysis insights into design, meaning taking your design back to Revit, and then a conclusion. Introduction to Forma. Formerly known as SpaceMaker, Forma is a cloud-based AI-assisted analytical software for simulation analysis that can enhance your Revit model and the workflow. As a cloud-based AI-assisted analytical software, Autodesk Forma leverages cloud computing and artificial intelligence machine learning to assist the analysis of architectural engineering and construction designs. Integrating with Revit models can be integrated with Forma. This integration streamlines the workflow for users who are already familiar with Revit. We will delve into the operations and the workflow of the user interface and the add-on option for live sync of the proposal made in Forma to Revit. And then early stage conceptual design. The focus on massing elements for early stage conceptual design implies that Forma is designed to assist architects and designers in the initial phases of a project when key decisions about massing and spatial organization are being made. This means less time spent in early stage design, the geolocated site with analytical data readily available such as temperature, wind impact, microclimate, noise analysis and more, thus saving time and money. So getting started with Forma. First off, sign in or sign up with your Autodesk account. You can check out the Forma blog, community forum and the YouTube channel for additional information on how to get started. Once you are signed in or added to a hub or created your own hub, you can create a new project, join existing projects as a member of that hub, or try a demo project where you can experience Forma in action with a pre-populated project. Different types of analysis available in Forma. The available analyses are area matrix analysis, sun hour analysis, daylight potential analysis, wind analysis, microclimate analysis, noise analysis, solar energy analysis, or analyses by extensions. By utilizing these analyses, Forma users can gain valuable insights into various aspects of their design, facilitating better decision-making and design optimization. There is a help feature at the bottom right within Forma for additional information regarding each analysis. Today's topic will be focused on daylight potential analysis. Introduction to daylight potential analysis. What is daylight potential analysis? Daylight potential analysis in Autodesk Forma is a crucial tool for assessing how much natural light different areas of a building will receive. This analysis uses a vertical sky component score to evaluate and visualize daylight availability on building facades. By understanding these metrics, designers can identify areas that may suffer from poor daylight exposure and make informed decisions to enhance the overall quality of the indoor environment. Why is daylight potential analysis important? Improving indoor environmental quality. Daylight is a vital aspect of indoor environmental quality. Adequate natural light enhances occupant well-being, productivity, and comfort. Poorly lit spaces can lead to health issues and reduce satisfaction among occupants. Energy efficiency. By maximizing the use of natural light, buildings can reduce reliance on artificial lighting, thereby lowering energy consumption and operating costs. This contributes to more sustainable and environmentally friendly building designs. Regulatory compliance. Many building codes and regulations require specific daylight levels in habitable spaces. Daylight potential analysis helps ensure compliance with these standards. Avoiding costly redesigns and delay during the approval process. How does daylight potential analysis work in Autodesk Forma? The daylight potential analysis in Autodesk Forma employs a model of an overcast sky to predict illumination on building surfaces. This model is independent of the sun and weather conditions, representing a heavily clouded day in September. Modeling the building. Import your building model in Autodesk Forma and set up the analysis parameters, or create your model in Forma with the massing tools available. The software uses the overcast sky model to simulate how light interacts with the building surfaces. Calculating the sky component score. The analysis calculates the vertical sky component score for different facade areas. This score indicates the percentage of the sky visible from a given point on the building facade, providing a measure of daylight availability. Interpreting the results. The analysis results highlight facade areas with inappropriate levels of light. These areas are indicated by color, ranging from light to dark blue, where larger windows or layout changes are needed to improve daylight conditions. Conversely, areas with good daylight performance are also identified, allowing designers to maintain or enhance these conditions. The color legend is displayed at the bottom of the analysis window. When hovering your cursor over the color legend, there is a description what each color represents. On the screen you will see less than 5% means achieving reasonable daylight is often impossible. 50% and more means conventional window design is usually satisfactory. Making informed design decisions. Using the VSC scores, designers can make informed decisions about window placement, facade design, and interior layout. This helps optimize natural light distribution throughout the building, enhancing the quality of the indoor environment. The practical applications of daylight potential analysis. Optimizing window placement and sizes. By analyzing VSC scores, designers can strategically place windows and adjust their sizes to maximize natural light penetration. This ensures that all areas of the building receive adequate daylight, improving occupant comfort and reducing the need for artificial lighting. Enhancing building layout. The analysis can identify areas where changes in the building layout are necessary to improve daylight conditions. For instance, reconfiguring room orientations or adjusting floor plans can enhance natural light distribution. Addressing challenging light conditions. The analysis results highlights areas where achieving reasonable daylight conditions may be difficult or even impossible. In such cases, designers can explore alternative solutions such as adding skylights or using reflective surfaces to enhance light diffusion. Meeting regulatory standards. Ensuring compliance with daylight-related building codes and standards is crucial. The daylight potential analysis helps designers meet these requirements, facilitating smoother approval processes and avoiding costly revisions. Lastly, supporting sustainable design. By optimizing daylight performance, the analysis contributes to more sustainable building designs. Reduced reliance on artificial lighting lowers energy consumption and carbon footprint, aligning with green building principles. In conclusion, Autodesk Forma's daylight potential analysis is an indispensable tool for architects and designers aiming to create well-lit, energy-efficient, and comfortable indoor environments. By providing detailed insights into daylight performance, this analysis empowers users to make informed decisions that enhance the overall quality of their buildings. Understanding vertical sky component. What is VSC definition? By definition, the daylight potential analysis output is a sky component measure of how much light reaches the facades from the sky, shown as a percentage score. For different points on the building, the sky component score indicates how much light would shine through a window placed at those points. For the usual use case of daylight and vertical facades, sky component is referred to as the vertical sky component. BRE, Building Research Establishment in the UK, explains VSC by the following definition: ratio of the part of illuminance at a point on a given vertical plane that is received directly from a CIE standard overcast sky to illuminance on a horizontal plane due to an unobstructed hemisphere of the sky. Generally put, it describes the following ratio. Sky component is expressed as a percentage. The illuminance on a horizontal surface, example an empty space, without obstruction is defined as 100%, whereas the illuminance on a vertical surface, example a facade or a wall, without obstructions is almost 40%. The reason this is not 50% is due to the sky model used, CIE overcast sky, where the sky at the zenith is 3 times bigger than at the horizon. The vertical sky component compared to daylight factor. Daylight factor is a measure commonly used for evaluating daylight conditions. The DF analysis assesses illuminance inside the room of a building, whereas VSC analysis assesses illuminance outside on the facade of the building, where VSC only measures for direct light from the sky on the facade. Daylight factor uses knowledge of window details and material reflective properties to measure direct and reflective light coming in through windows and potentially being reflected indoors. However, direct light from the sky through a window is typically the main contributing factor to a DF score. And VSC can therefore provide a good earlier predictor for indoor daylight performance. Daylight factor and VSC vertical sky component are both defined to use CIE overcast sky model. National guidelines and threshold values. Some countries have legislative requirements to ensure adequate daylight, while most have informative codes and standards requiring sufficient daylight without mandatory levels being defined. Forma uses BRE's suggested threshold to predict daylight performance. The thresholds are targeted to predict an average daylight factor of 2%. VSC default threshold given a target of 2% daylight factor. Setting up daylight analysis in Autodesk Forma. Setting up the daylight factor analysis in Forma to enable you to do the analysis. Step 1 is to import an external model in IFC or OBJ format, or create a new proposal within Forma with the tools provided. Place an imported model in the canvas or create a new proposal as a base layer situated in the specified geolocation. This means searching for your site on the available global map and placing a base layer where you specify the site using the tools available within Forma. Step 3. Analyze the imported model or newly created structure to do AI-assisted simulations, for example, sun hours, daylight potential, and other possible analyses. Step 4. You can also import a reference image file, such as a JPEG or PNG, if you already have a layout which you wish to create within Forma, which can be drawn and extruded. Step 5. You can detail the model in 3D sketch mode with the toolsets available. Step 6. Once you have created your base layer and the 3D extruded mass, the options are there to compare analysis results. When the satisfactory analysis is completed, you can send the mass to Revit with the Revit add-in extension from Forma. Step 8. Load your proposal in Revit under the Massing and Site tab in Revit and send the Revit model back to Forma for further analysis after you've made some changes. Import an external model or ordered data such as street maps, terrain maps, roads and railways, contours, etc. You will find in Forma on the left hand side your library, extensions, and where you can add members. File import from library. Forma currently supports importing the following file formats. Mesh is OBJ or IFC for 3D geometry. Vector import for 2D geometry is DXF, or you can import raster images such as JPEG or PNG. Forma currently only supports files smaller than 100 megabytes. So how to import the files? While in the library, click Next. You will see the icon available there on the left for the library pane. Navigate to the Import tab. Once you've clicked on the Import tab, you will see the drag and drop files to import available. Depending on the file size and type, the important process may vary in duration. Once you see loading window, you can either wait until you see the preview or close that window. The library shows a loading status of your import and allows for reopen the configuration window by clicking on the 3 dots menu, and you can import parameters once your import process is done. Detail the proposal in 2D or 3D sketch mode in Forma. With the data used for your base layer, you can now create your proposal with the tools provided by Forma. Create proposals with the building tools available in the design menu. This is just an overview of what is available. With each of these options, there are additional settings and parameters that can be defined. First, we have buildings. You get line buildings, basic buildings, and house types. You can create different house templates, change the size, the amount of floors or levels, the roof type, such as a monopitch, at any angle and direction. You can name the house type, make changes to them, create new ones, and add a function to your house type. And this can then be placed in Forma on your site. Next, you have vegetation, tree lines, and areas with trees. You have limits, such as site limit, your zone or the constraint, the area that you wish to place your model, your building or structure. Transportation, such as roads and railroads. Generic is just a generic volume or surface or a line to indicate what you need to indicate on your site for your proposal. Then you have 3D sketch mode. This is only to iterate the early stage architectural concept. And then additionally, you can measure any distance between 2 points, add labels to mark specific points in the 3D canvas with a short description. You can add up to 5 lines of text or add extensions, as well as move and rotate all the elements placed in your proposal. Then you have control over your visibility and orientation toolbar. In the lower right corner in Forma, you can access the following tools. You can check on and off snapping for your elevation above sea level at cursor. Toggle between terrain map, texture, contour lines, and satellite imagery. Save a camera position and load a pre-saved position. Look from a point or zoom to fit the entire proposal in the view. You can switch between 3D and 2D view, and you can also orientate to true north orientation. Okay, next I'll do a short demonstration. If you would like to have access to Autodesk Forma, you can go to this website to try Forma for free, the free trial version. Or if you already have AEC collection, for example, you can access Forma from your Autodesk account. I've created a project as part of this demonstration to showcase the daylight potential analysis compared to other analyses. So on the screen, you will see from the top left, this is the home page. To navigate back to the home page. On the home page, you're able to create new projects once you are part of your hub and that you're signed in. You'll find on your homepage, you have access to all of these options. However, you can go and see all your projects that have been created, gain access to them, add members, additional settings, and you can also folder them if you would like to have them in a foldered structure. So let's look at our first example. I gave my project name Sagrada Familia in Barcelona. On the top left here, you have access to 3 different view spaces. This is called the mode switcher. So this is site design, where you have access to the model, the entire site that's been loaded. You have a board where you can create a presentation, such as a mood board, to share with stakeholders, shareholders, with the owner. And then also the compare option, which we'll take a look at, where you can compare different types of analyses that you have run. You're able to lock your design if you do not wish for anyone else in your hub to gain access without invitation, or you can open it so anybody in the hub can gain access to your design proposals. Here you're able to add members, invite members by email, and have access to everything we see displayed here. On the left hand side, this is where we find the library, where you can create your own house types and import them. You can import or order data. And here are extensions if you wish to add additional extensions to your model. Okay, so as an example, I created 2 proposals to show you that even though we have the same site, I can have more than one design. You can load additional proposals to your project. So as here is an example, this is a site limit that I set, saying that this is the site that we will be working on. And there was a second site that I'd created as an example. In proposal 1, you will see the design change with different structures available. Here is an imported model from Revit. This is created in Forma, and this is the house type created in Forma. Added a road and some vegetation. Here is the examples of the labels. You will find the label function here. Any of these functions, when you hover over them, it will give you a short description of what it does, or you can press H for more information. On the top right here is where we do all the different types of analyses. You can have your area metrics displayed. You can do it by the zone that you created. the area you specified or by the structure itself, and it will give you the overview of those structures. You can also do this for specific units if you have units within a building, like that building at the top there, or if you have parking lots that you have created. It will tell you how many parking spaces are available. So the daylight potential analysis by itself, here you can go and learn more regarding the vertical sky component score and how Autodesk utilizes this score to determine your analysis, how it's created. Then you're able to click on Run Analysis. The analysis can be done either by selection of my two sites, is what I selected. I would like to do analysis on those two, or you can do it on the entire model, which will then take the entire space that you specified. And then you click Run Analysis, and this will create the analyses. While this is running, I will go and show you my history. I have done a few analyses in the past, so I can show you guys what the daylight potential example looks like. So at the top left here, you have the option to go between your different proposal types. So I have my proposal 1 and proposal 2. And when you click on your proposals, all the analyses that you have done on those buildings on your site will be displayed here. I've done a wind, microclimate, sun hours, solar energy, and so forth. So the daylight potential itself, as explained earlier, here at the bottom you see your color legend telling you where there will be insufficient light on your structure. You can make design changes or understand the necessity for the design where there won't be sufficient daylight, and use bigger windows, make use of artificial lights, what you need. And then conventional window design, usually satisfactory, is displayed here by color. On the right hand side, here it is displayed by facades. So 1% of my structure that I created is less than sufficient. It's less than 5%. Here you have the inspect tool. You can click on the inspect tool to start the inspection, and as you click on your design, you can find where there might be insufficient daylight potential. Here at the bottom, you can go make changes to the shadows. You can go change the time, the year, the month and the day, and the time of day. As you do, you will see the shadows move along, indicating what it would be like on that day, that month, and that time. Here you have options to save camera position. So let's say you want to have a presentation and you decide this is the view that I want to see. You can save this as a camera position, give it a name, and the camera position will be saved. So even if I navigate away, if I quickly want to go back to that, I can just click on a previously saved camera position. If you're happy with the results that you see, you're able to create a 4K screen capture, or with graphics if you added graphics to it. And this will give you a PNG file that you can send on as a part of your presentation. Also, you are able to then compare, so you can also share this to someone, inviting them to the project and sharing the information with them. Here's the compare tool. So previously I stated here we had the site design, now we're at the compare tool. With the compare tool, you're able to take previous analyses that you did and compare the results. Also, if you want to use the same type of analyses to compare what it was like to what it is now, after you made a design change, if you did make a design change, you're able to compare these results. Okay, here you have the wind factor indicating what the wind conditions will be like if it's from the west, northeast, and there's your structure regarding your proposal for your daylight potential. And you're also able to, you can add multiple different types of analyses at the same time. If you right click, you can split the space to add additional analyses that you have done. And with all the analysis types, you will have a very good indication of the comfort level that a person will have walking past the structure and what the structure itself will have. With the inspect tool, you can then go and make some inspection and see how much sun hours you will gain at certain points, what the wind speed will be like, what the temperature on the ground will be like, and this will indicate your comfort level within Autodesk Forma. Once you're done with all your analyses, you're able to save these images and you can take them into your proposal, your board. This is similar to, I guess, a mood board of sorts. You can take those images, you can load the image that you just created, and you can paste it in here. You can add comments to them. Here's an example of one of the comments. You're able to add text and make a proposal. Once you're happy with this, you can either invite a member to this, or you can share the project. You can invite them by link or send them an invite by email, where perhaps the owner would like to just view what has happened, what the comfort levels will be like, to collaborate, or to add them as an administrator of the project to make changes. Okay, so interpreting daylight potential analysis results. In a project, select daylight potential from the right pane menu. To run the analysis, select one or more site limits or zones or the entire model from the analysis selection menu to define the area where the analysis will be computed, and then click Run Analysis. If you would like to know more about each type of analysis, there is a help function on the right side pane. There you can join and ask the community to learn essential workflows, contact Autodesk support. There are tasks that you can do and news about Forma and the analysis that you are interested in, upcoming and new features and more. How to further interpret the daylight potential analysis results. If the VSC score is equal or greater than 27%, this means conventional window design is usually satisfactory. 15 to 20%, larger windows or design changes are usually required. 5 to 15%, it is difficult to provide adequate daylight. It will require some artificial lighting. Less than 5% generally means achieving reasonable daylight is often impossible. Additional capabilities of Autodesk Forma's daylight potential analysis. Comprehensive daylight distribution analysis for multi-story buildings. The tool can assess daylight availability across multiple floors, providing a vertical distribution profile of natural light. Integrating with other environmental analyses, combined with thermal comfort, daylight potential analysis can be integrated with thermal comfort analysis. This helps in assessing the impact of daylight on indoor temperatures and thermal comfort, enabling a more holistic design. Energy performance correlation. The insights from daylight analysis can be correlated with energy performance metrics. This allows for a comprehensive understanding of how daylight strategies affect overall energy consumption and efficiency. So sun hours, as I showed in the demonstration, With the sun hour analysis, a comparison can be made for further understanding the level of comfort a structure will have. Visual and reporting tools. Detailed visualization. Forma provides advanced visualization tools to create detailed, color-coded maps of daylight distribution. These visualizations make it easy to identify areas with optimal and suboptimal daylight conditions. The custom reports. The tool can generate comprehensive reports that include analysis results, visualization, and recommendations. These reports can be used for stakeholder presentations, regulatory submissions, and internal design reviews. The project can be exported as an OBJ file and shared with others. It can be sent to Revit for further development and preparing for a presentation. A 4K screen capture can be saved and sent to stakeholders, and members can be added to the project. Scenario planning and comparison. Design iteration comparisons. Designers can compare multiple design iterations to see how changes in building geometry, window placement, or material affect daylight performance. This aids in making data-driven decisions and to select the best design option. Forma can simulate the impact of surrounding buildings in urban context on daylight availability. This helps in understanding how shadows and reflections from neighboring structures influence the building's daylight performance. Integrating with design workflow. Forma seamlessly integrates with other design tools and workflows, allowing for smooth transitions between different stages of the design process and ensuring that daylight analysis is an integral part of the overall design strategy. And lastly, the educational and training resources. There are tutorials and documentation available. Autodesk provides extensive tutorials and documentation and user guides to help users get the most out of the daylight potential analysis tool. These resources can make it easier for both beginners and advanced users to effectively utilize the tool. The community and support. Users can access Autodesk support community and forums to seek advice, share experiences, and learn from other professionals. This collaborative environment fosters continuous learning and improvement. So interpreting daylight potential analysis results. So how to utilize the inspect tool for even more clarity. You can change the month, day, and time for the shadows on a specific day to have a better understanding of the environmental impact by the surrounding buildings or vegetation. So there are some limitations and some configuration and how the sky is determined. So the limitations, the VSC analysis does not take into account window sizes, building material or room sizes or room functions. The indoor daylight performance is dependent on these factors, and the amount of daylight required is usually different for different room functions. The purpose of the vertical sky component analysis is to be an indicator of the daylight potential. To determine the internal effect of the daylight potential, a daylight factor can be used. Daylight factor is a measure commonly used for evaluating daylight conditions. The DF analysis assesses illuminance inside the room of a building. However, this is not within Forma. Configuration. The daylight analysis initialized with a set of default configurations. These are set based on Forma's research and external research into standard values used in similar simulations. The sky. The design for daylight factor calculations is based on the CIE overcast sky for the 21st of September at 12 o'clock. The International Commission of Illumination, CIE, in French is for the Commission Internationale de l'Éclairage, is the international authority on light, illumination, color, and color spaces. The original CIE standard overcast sky model was originally published by Moon and Spencer in 1942. While the CIE standard overcast sky model has since been updated to a different mathematical definition, the traditional model is in practice and used in many different daylight simulations. This is the model used in the current Forma daylight potential analysis. The differences for the new model are small. Comparing the analysis results. Compare analysis example here for daylight potential and wind. With the comparison, you can view how the different aspects affecting your structure or building and how to rectify the design for the optimal comfort level. You can change the design and compare different design proposals to see how the impact of each type of analysis changes with your design implementations. Make changes to the display options orientation, utilize the inspect tool for clarity and detailed information. Change the month, day and time of the shadows and create a presentable analysis for the stakeholders. In conclusion, Autodesk Forma stands as a powerful and user-friendly design tool that empowers users to delve into the intricate details of their projects during the early planning stages. Offering a suite of sophisticated analyses, Forma provides architects, designers, and planners with the tools needed to optimize designs, improve efficiency, and make well-informed decisions. The diverse range of analyses from daylight potential and microclimate assessments to noise and wind analysis caters to a holistic understanding of a project's conditions and potential challenges. The ability to access hidden information and visualize critical data sets allows for a comprehensive exploration of proposed designs. What sets Autodesk Forma apart is its commitment to user accessibility. The cloud-computed analysis delivers instantaneous results, reducing waiting times and allowing for swift, data-driven design iterations. Importantly, Forma doesn't require in-depth technical expertise, making it accessible to a broad spectrum of users. Furthermore, the incorporation of machine learning in the rapid operational energy analysis demonstrates Forma's commitment to cutting-edge technologies, enabling real-time predictions and energy-efficient design considerations. As an invaluable tool for early-stage planning, Autodesk Forma facilitates efficient decision-making, minimizes consequences through result-oriented design iterations, and provides a platform for the comparison of different projects. By seamlessly integrating economic, buildability, livability, and compliance considerations, Forma contributes significantly to the success of architectural and urban planning endeavors. Whether used by seasoned professionals or those new to the field, Autodesk Forma stands as a testament to the transformative potential of design tools, allowing users to envision and realize projects with greater precision and confidence. If you have any questions, please do not hesitate to contact us here at Micrographics. I hope you found this webinar informative. If you haven't subscribed, please do so, and don't forget to like and hit that notification bell for future webinars. Thank you and goodbye.